Hi, my name is Theodore Mercado, Ample ID 5432. It is May 23rd, 2022. The part of the exam I on is part 1, and on my honor, I attest the work you are about to see is my own, and I am following the letter and rules by which this exam project is being given. The question I'm on right now is for part 1, group A. Present a brief explanation how calculating forces and torques in a physical exam like the human body, how it is possible to deduce the best way to lift an object without hurting yourself. So for this, I'm using the information given in lecture 5. I'm using the equations for torque and center of mass. This one over here was the information I used. But I have a sheet for the equations over here. So over here, we're going to be using these equations here. So if you can see, the first part here is for torque. So it's going to be the mass multiplied by the gravity, usually 9 I'm not sure if you can see it, 9.8 meters per second. I think it's usually called the downward acting force, as they called it in the lecture. So you're going to multiply that by the last part here is the distance. So I made a little diagram here very similar to what was shown in the lecture of a stick figure resembling a human. So it would be, if you're holding something with a certain mass over here, it would exert a force over here and here, or a torque, instance of force, which would be measured in newtons per meter. So you can find that through this equation up here for torque. And then when showing the mass of an object, the center of mass, you can compare them here by taking two torques, which is the exact same equation up here, and equaling them to each other to see where the center of mass would be, which is again going to be in newtons per meter. So when doing this, it is extremely important that your center of mass is about even, because if you're lifting something off the ground, which is why G, or 9.8, is used in the equation, you're going to be exerting force distributed throughout your body. So like in this stick figure here, the center of mass, if he's holding it here, would most likely be somewhere in the middle of his elbow or so. But if you were to bend down, that center of force would now be down to your lower back, which is why people can have lower back problems if they're not lifting with the proper body mechanics. So because of that, you just want to have a good idea of your center of force and your torque to minimize damage to other parts of your body. That's why they always say lift with your legs, or lift with your arms and your legs and not with your lower back. So that's all just torque and center of mass.